Okay, so let's practice some of these. When we look at number 1, we're asked to solve the right triangle. So I got to tell you, I'm going to use a separate sheet of paper to make sure I can spread my work out and you can see the solving process so that it's easier for you. If I have a 42-degree angle, remember when you're solving a triangle, you're looking for 3 angle measures. I have 42, I have 90. All I need to do is subtract 42 from 90 and get my 48-degree angle for T. So I'm halfway there. I have my 3 angles. When I look at my sides, I have my hypotenuse because it's opposite the right angle. And whether I use 42 or 48 is up to me. I'll go ahead and call 42 my theta. I like using the angle that I already have. So in case I messed up on my math here, I don't mess up the rest of my problems. So I'm going to go ahead and say, okay, I have my hypotenuse. I need my opposite and I need my adjacent. I'm going to solve for my opposite first. So U is my opposite. So I know that the sine of 42 degrees is going to be equal to the side opposite divided by the hypotenuse. Now I went ahead and used my little trig ratio post-it to make sure that I remember some old hippie caught another hippie tripping on acid, or SOHCAHTOA, whichever way helps you remember those trig relationships. So my side opposite, I don't know. That's what I'm looking for. My hypotenuse is 15. I can fill that in. All I need now is the sine of 42 degrees. So I can go to my chart. I can find 42. And I know that my sine is going to be here, 0.6691. So this decimal value, 0.6691, is the unit rate of this comparison for that degree angle. Now, if you have a calculator, you can go ahead and use your calculator to give you that same value. Remember, you have to go to mode and make sure it's in degree. Once you're in degrees, you can ask the calculator, what is the sine of 42 degrees? Notice it's going to give you the same value that my chart did. Now, it's an irrational number. It's not an irrational number. It is a number that divides out with many decimal places. So we are going to go always and round to the nearest 4 decimal places. So from this point onward, we're back to just solving for values in a ratio the same way that we did last unit. If it's already in my calculator, it's easy to just use that times 15. And I know that U has a value of 10.0. I'm going to look out and round up to 0.04. Trig values to the nearest 4 decimal places. Sides to the nearest 2 decimal places. Angles to the nearest whole place. All right, so now that I have U having a value of 10.04, it's my choice to solve for V. I can either use Pythagoras, a squared plus b squared equals c squared, or I can just use another trig ratio. I can say, okay, the cosine of 42 degrees is equal to the adjacent compared to the hypotenuse. I can go back to my chart, look at 42 degrees, and look at the cosine value, 0.7431. 0.7431 is the cosine of 42 degrees. That is equal to my adjacent side, 15. Oh, my adjacent side, I'm sorry, that's V, compared to 15, my hypotenuse. I can put this over 1, and then I can use cross products to solve. V is equal to 15 times 0.7431. V is equal to, and I can use my calculator, And I could say, what's the cosine of 42 degrees and not use the chart. Notice that value is locked in. And I can say, what is that times 15? So my V value is 11.15 when I round. So the interesting side of this is there's more than one way to get these values. Whether I use 48 and have my opposite adjacent, 42 degrees, have my opposite adjacent, or if I use Pythagoras. My goal is to have 3 angle measures, 90, 48, 42, and 3 side measures. Here's the measure for U. Here's my measure for V. And then, of course, my 15 I already had. So V is equal to 11.15. The neater you are in your work, the better. So we want to make sure that when you're working on these, you take the time to do your work and keep track of it so that you can go back and find any mistakes that you make. All right, let's check out triangle number 2. So for number 2, let's talk about what we have. I have a 65-degree angle. I have my side opposite. So here's my opposite. Here is my side that's adjacent, and here is my hypotenuse. So I can go ahead and solve for my missing angle. All I do is 90 minus 65. Oops. So I know that the measure of angle F here, my B value, is 25 degrees. I'm going to still use this 65 for my angle measurement for my theta. I'm looking for the hypotenuse, so I can say the sine of a 65-degree angle is equal to the opposite compared to the hypotenuse. I can either go to my chart or my calculator and say, what is the sine of 65 degrees? And know that that's 0.906. 3 is equal to, go back to my triangle, my side opposite is 8, and my hypotenuse is what I'm solving for. And I can do some cross products. 8 is equal to 0.9063 times x, divide by 9063, divide by 0.9063, and I can have my x value. Since I know that I'm going to be dividing, I can go ahead and say, what is 8 divided by this last answer? If you want to put that into the button, you're using the ants. It's the second ants, and it'll type that value in for you. So that x value has a value of 8.83 when I round, which means that this hypotenuse value is 8.83. Let's talk about our adjacent side. Now again, rule of thumb, I always like to use what's given to me. So if I'm looking for my adjacent and I have my opposite, I'm going to go ahead and use my tangent because that's my ratio of my opposite to adjacent. So I know that the tangent of 65 degrees is equal to the relationship between my opposite and adjacent angles. So my tangent of a 65-degree angle, tangent of 65, 2.1445 is equal to your side opposite, that's 8, divided by what you're solving for, which is y. So I'll say 2.1445 times y is equal to 8. Y is equal to 8 divided by 2.1445. So y is equal to go back to the calculator, 8 divided by, and I can either type this number in or just ask the calculator to go ahead and give me that value again. I can put my answer in like I did last time. I could type it again, or I could actually type the value in. Either way, you'll get the same answer, 3.73. That is the value of this side, 3.73. So in solving the triangle, do I have 3 angle measures? 1, 2, 3. Do I have 3 side lengths? 1, 2, 3. I'm good to go. All right, let's take a look at number 3. So for number 3, I'll go ahead and make sure you can see what it is that I'm doing. And we'll look at this next triangle. Uh-oh, this is our first one where I don't have either of my angle measures. So I have to choose one. It's going to be either this one or this one that I mark as my theta. Either way, you're going to get the same answer. It just determines which of the sides are your opposite or adjacent sides. All right, so let's go ahead and let this one be theta. It could be either one, it doesn't matter. But once I choose my theta, now I have my opposite side, I have my adjacent side, and of course this is always my hypotenuse. So I have my opposite, I need to find my hypotenuse, I need to find my adjacent. So knowing that I have my opposite, the two trig functions, the two relationships I'm going to use are sine and tangent. So setting up this one is a little bit different. I know that the sine of my theta, whatever angle it is going to be equal to my opposite over my hypotenuse. But here's my problem. I don't have that measure yet. So I either need to use Pythagoras to solve it, a squared plus b squared equals c squared, or I need to start off with my tangent. So let's go ahead and start off with our tangent. Our tangent of this angle is equal to my opposite divided by my adjacent. I have those two measures. So I know that for my theta, my 7 is my opposite. I know that my 12 is my adjacent. And the relationship of whatever angle of tangent fits that. So I've got two choices, either chart or calculator. So if I want to use my chart, 7 divided by 12 is equal to this ratio, 0.5833. So the tangent of some angle is equal to that. So if I go to my chart and I find a tangent of 0.58, see how I'm right in between here, these two values here? 0.58 is going to be somewhere between 30 and 31. So my job is to choose which one it's closest to. It looks like it's closest to the 30, so we'll call that a 30-degree angle. So we'll say that theta is then equal to 30 degrees. The calculator can also find this for us. So you can say, by using your inverse functions, so if you can see above the tangent, there's a blue tangent to the -1. We call that the arc tangent sometimes, or the inverse. We ask the calculator for, tell me the angle measurements, and I have to use the second function in order to get that -1. Tell me what angle has a tangent ratio of 7 divided by 12. And it's going to tell me a 30-degree angle. And like I said, we take angle measures to the closest whole angle. So in my triangle, I know that if this angle is 30, then I know that this angle is going to be a 60-degree angle. And if you want to go ahead and solve for your hypotenuse, you can use your shortcuts. So this will be twice that measure. Now, because we rounded a little bit on our angle, chances are it's not going to be exactly 14. So if you want to, we can go ahead and do the math and see how that works. If I have a squared plus b squared equals c squared, 49 plus 144, let's see, 49 plus 144, I'm a little off from 196, which is 14 squared. So if I need to take the square root of that value, 13.89, it's going to be pretty close. 13, we'll keep on solving. So C is going to be equal to 13.89, that value for C. So whether you look at our trig ratios to help you solve for the angle, Pythagoras, I could have also used a trig ratio to help me solve. So I've got 1, 2, 3 sides. I've got 1, 2, 3 angles. I'm good to go. We can move on and take a look at number 4. So try to move things around. Give ourselves more room here. When we're looking at number 4, we have, again, 2 side lengths, but no angles. So I'm going to make this one my theta. I'm going to call this one my opposite. This one is my adjacent, and this side is my hypotenuse. I have my adjacent and my hypotenuse, so the cosine of my angle theta is going to be equal to my adjacent divided by my hypotenuse. That's this relationship here. All right? So my hypotenuse, I know, well, I can put that cosine adjacent over hypotenuse. Okay, so my cosine of my theta is going to be equal to 8 divided by 30. So I'm going to go to the calculator. I'm going to say, hey, calculator, which angle? I'm going to use my second function, second and cosine 1. Which angle has a cosine of 8 divided by 30? And that's going to tell me your theta angle is going to be equal to, round up to the nearest whole angle, 75 degrees. So when I look here, my theta angle is 75 degrees. My complementary angle is going to be 15 degrees. And I have 1, 2, 3 angles of the triangle. I've got 2 sides. So now I need to decide how I want to get this other side. And I can use Pythagoras or I can use a trig ratio. Totally up to you. If I have my 75 degree angle, and I can go ahead and say, okay, I have my opposite and adjacent. If I said the tangent of 75 degrees is equal to my opposite divided by my adjacent, I could ask the calculator, hey, what's the tangent of a 75 degree angle? What is that relationship? And it'll tell me 3.73 to 1 is equal to my opposite. That's what I'm looking for. And we can call that x. And my adjacent I have. So my x is equal to 8 times 3.73 to 1. And then I can go ahead and just do this math that's already in my calculator times 8. So I can say that side length is 29.86, round up to 2 decimal places. So I have 29.86 is my side length. So 3 sides. Now you can check and see how accurate you are by testing this through Pythagoras. Is 8 squared plus 29.86 squared. Oops. Let me clear that out. Is 8 squared. Don't forget to arrow out. Plus 29.86 squared. Are those two values equal when you divide by 30? So when I go ahead and I divide, what is the square root of this value? Pretty close. We have some margin of error. Okay? All right, so I want you to try 5, 6, 7, and 8 and come back and check your answers with the video. We're going to pause, and I'm going to solve, and then come back, and you can check your work. So go ahead and pause. All right, so let's check out 5. When I did the tangent of theta, I made angle B my theta. And when I said the tangent of theta is equal to the opposite over adjacent, I went ahead and divided 5/4. And I said, hey, tell me the angle whose tangent is equal to 5 divided by 4. And I got a 51.3 degree angle. Now what ends up happening here is when you round, you introduce a margin of error. So if you're concerned about the level of accuracy, there's going to be some leadway in our answers. So when I have a 51-ish degree angle, I've rounded and lost this accuracy of 34/100ths. So the interesting thing is there's two ways to go about solving for this. My third side, I can do Pythagoras, 25 plus 16, and then I can get that square root. I can continue working with the trig functions, but knowing that that's going to be less accurate of an answer because I'm using a value that's been estimated. So keep that in mind. That's why one rule of thumb that I always use when I'm working with values is I'm going to make sure that I use whatever's been given to me. And this one's a really good example. When I solve this one using Pythagoras, I get an even answer. I get 56 because this is a Pythagorean triple. When I go ahead and use the trig functions, I end up rounding, recognizing that, wait, this value here is a 30.5 degree angle. It's not a 30 degree angle. So if you're curious about whether or not our shortcuts would have worked with this one, maybe not, because if I'm rounding to the closest angle, it's really, I end up talking about a 31 degree angle. So we want to make sure that we use whichever information is guaranteed without using our estimates. So 7 and 8 hopefully were no work for you because you had a 30, 60, 90 degree triangle. So my hypotenuse is twice my short leg, and my long leg is root 3 times that. My 45, 45, 90 isosceles right triangle left me with a hypotenuse of 6 roots of 2, which meant my sides were each worth 6. So the shortcuts, don't forget about them, they still apply. All right, so you have a math space to work on next. So hopefully you're feeling good about this and you can do those math space problems now.